of our continued Element 14 Innovation Series, I'm delighted to have the chance today to speak to Andrew Strain, VP of Engineering at Clyde Space, a specialist creator of small and micro spacecraft systems for satellite missions. Right now, Andrew and his team are developing a nano satellite platform, working with the new UK Space Agency on a pioneering mission. So these are exciting times for the company and the future of space technology. With a focus on innovation and experience of over 50 space programs, the team at Clyde Space is able to offer a very unique experience to its global customers who come from a wide range of leading global academic and commercial organizations. As the Clyde Space engineering team push at the boundaries of new technology, commercializing its use and bringing it to market in an affordable way, we are pleased to have been able to support them in their research and development work through our Element 14 community and extensive technical support services. So let's get started on today's interview. Andrew, thanks for joining us today and giving our community an insight into the exciting world of space. Can you start by giving us an introduction into the products and the services that Clyde Space provides?
Certainly. Thank you for your introduction, which is probably almost better than what I could do. But Clyde Space as a company make systems and subsystems for a range of small satellites. So anything ranging from a 10 by 10 by 10 centimetre cube up to something that would be about the size of a normal desk that you would work at. So we've been around for about 6 years and got involved in making very small satellites that are technically innovative and slightly new compared to what normal space applications have been in the past, pushing the boundaries a little bit more than perhaps has been over the last few years in the space industry.
So is the use of satellites growing, Andrew? Is this a burgeoning environment?
Absolutely, particularly in the very small satellite area. There are, over the past 6 years, while Clyde Space have been involved, the CubeSats in particular, which are the very small satellites, and I can actually show you one. This here is an actual CubeSat, so that's the size of the CubeSat, the satellites that we're dealing with. The growth of the CubeSat market has been almost exponential because people in the past have been very adverse in the space industry to new technologies and new ways of doing things due to the high cost and high risk. They tend to stick to what they know. But with the advent of CubeSats, which came from an academic organisation in the United States, a lot more people are seeing the opportunities and the possibility of getting into space missions and activities and actually it being affordable for them to do that. So it's something that has been growing massively over the last few years and hopefully will continue to do so.
Mm-hmm. And as you say, Clyde Space is kind of known for its activities and leadership in CubeSats and have been involved in many, many firsts. Can you tell us something about your exciting work with the UK Space Agency and where that satellite will be going?
Sure. We are currently working on a mission called UCube-1, which is the first satellite of the UK Space Agency. And what we are doing with that is we are making the kind of guts of the satellite and the core systems that you need for the satellite to be able to operate correctly, that you need in any satellite. So we're doing the power systems, batteries, solar panels, and the kind of heart of the satellite that you need. Once we have integrated all of that, which we're working on at the moment, we'll then bring in the payloads. And the payloads are the experiments or the technical demonstrations that the satellite's been created to enable to work in space. So with the payloads in place, and that complete satellite will be launched at the end of this year, going into an orbit around the Earth of around 600 kilometres in height, and that satellite will orbit the Earth every 60 minutes approximately, so it's moving fairly quickly for such a small object. And the payloads that are going on were selected by the UK Space Agency. They had a competition last year to try and raise awareness and get some really innovative payloads in. So the 4 payloads that have been selected were a range of different things, because with these small satellites you can do so many different things. It's a really great opportunity to be able to push the boundaries. So we have a brand new CMOS imager camera, which is being worked on by E2V Technologies and the Open University. We have a radiation sensor. Normally in the space environment we want to protect against radiation, but one of the payloads is actually taking the radiation information and looking at a way of encrypting data using the random operation of radiation. We have another payload which is a simulation of even smaller satellites than the ones we're making at the moment, to try and take the next step forward. And we also have the Fun Cube, which is a cube setup which allows many people to talk to the satellite. So it's actually, that one's been designed by the AMSAT UK. So it's the amateur satellite people, and you can buy a dongle for that, which you plug into your laptop, which means that once UCube 1 is launched, anybody in schools and universities all around the world will be able to actually talk to the UCube satellite.
Wow, wow. That's amazing. So how do your engineering team use Element 14 and our engineering solutions like the Element 14 node?
It's a fantastic forum for engineers, and being able to find new developments, new technologies, and it's a great resource to be able to talk to other people about the capabilities. Coming from a particularly risk-averse industry, people want to know as much as they can before they're willing to fly certain technologies. So being able to access the information and have such a wide community it speeds things up a lot. And if the faster you can get through things, the more you can push the boundaries of what you're trying to do. So it's a great community to be able to have access to.
That's great. Well, thank you. Now, rumor has it that your design team have ordered one of the new Raspberry Pis. What do you plan to use it for, and are you excited by this technology? Could it even be the first one in space?
Well, as much as I would love to say that we are always forward thinking and pushing the boundaries ourselves, we were slightly slow off the mark on this one. So I haven't been able to get my hands on one yet, but I have registered my interest to be able to get one of the Raspberry Pi. And I think it's a great example of technology being used in a slightly different way that opens up a lot of doors. So as an engineer, I want to get my hands on it to see what it's capable of, and there's certainly no reason why it couldn't fly, considering some of the other technologies that have flown before. So it's definitely a possibility.
Great. So what careers advice would you give to young space engineering hopefuls of the future? I saw the Build Your Own Cube Sat Kit on your website, which looks like a very good place to start. But what advice would you give?
I think the best advice is things like the CubeSat kit and a lot of the information that's now available are fantastic ways for young engineers to get involved in engineering and really be invigorated about what they're doing and what engineering can do. I think you need a good grounding in technology type subjects and things like that, but also I think it's important for people to realise that space is something that lots of people can get involved in. For example, I was born in Glasgow, educated in Glasgow, and now I'm working in a space company in Glasgow. Space isn't something that you need to go to Houston, Texas and work for NASA to work in. It's something that we can all be involved in, and with projects like UCube and the AMSAT FunCube, where people can actually see directly how they can get involved. I think it's a great opportunity to engage in the space industry. And to be honest, it shouldn't be difficult to get excited about working on projects that are going into space. And while we're on the subject of education and outreach, what do you think Element 14 does for the design engineers of tomorrow, Harriet?
I think it's kind of similar to what you said, Andrew. Those of us working in the technology space, I think, have a responsibility to invest in and encourage the next generation of design engineers and programmers if we are to continue to innovate at the pace the technology world requires and ensure that we keep pushing the boundaries. And so Element 14 already has a very active educational forum and is used by universities, particularly to access the very latest product information, download our freemium Eagle CAD software, commune, share ideas in any language, and even create, prototypes. So one of the reasons we were so keen, to partner with a whole range of companies, Raspberry Pi is just one, is to really encourage people to see the difference that one can make, to encourage maybe lost skills or skills that people don't feel that they can embrace, so that we have a new generation of programmers, innovators, and would-be space engineers. I think that's important. So I would like to ask you one kind of non-engineering question. Do you think there are other civilizations out there in space?
That's a very big question. I certainly would like to hope so. There's a vast expanse out there, and it would be really exciting to have contributed to us being able to find other civilizations out there, and maybe when we do find our neighbours, we can load up a CubeSat with a Pi and send it across to them.
That's great. And then finally, we always like to ask our leaders of the great innovation companies, kind of what keeps you awake at night? Are you worrying about a particular technology, excited about a new development? If I may be so bold, what keeps you awake at night?
Well, with missions like UCube orbiting the Earth every 60 minutes, there's no time for sleep. There's always more information to be grabbed hold of so that we can improve for the next mission. So having to take down all of that information keeps me awake at night.
Yeah. So, Andrew, thank you very much for your time today, especially in a week when I know you've been running a major space symposium and preparing for a very big TV interview. So, in closing, I would just ask what you think is the next big thing in space technology.
Well, there's a lot of people talk about the next big thing being space tourism and larger things like that. But to me, the next big thing in space is the small things. The capabilities that we can now fit into these small satellites that used to require a satellite magnitudes of size larger is quite incredible. And if we continue to improve what we can send up, then there's really no limits to what we can achieve.
That's wonderful. Thank you so much, Andrew. We look forward to hearing updates on Clyde Space's exciting work via Element 14. So thank you very much indeed.
Thank you.